Okay, so now we're going to do this integral. And the sort of new thing here is that the curve, instead of a line, is going to be a curve. So let's go to Desmos and see what this looks like. The green square is the square 0, 2 cross 0, 2. And then the blue line, or the blue curve, is the curve xy is equal to 1. Or xy is equal to 1. Okay, and we want to know the integral that is inside this square and below xy is equal to 1. So it's this region right here. Okay, and we're going to compute this integral, and we're just going to do it with the x integral on the inside. Okay, so x is going to go from something to something, and y is going to go from something to something. Okay, so do the x integral on the inside. That means that for every fixed value of y, we're going to go like this. But observe something happens. This is 1/2. Above 1/2, x is going to go from 0 to 1 over y. But below 1/2, x is going to go from 0 to 2. So we have to split this integral up into two pieces. We're going to have one when x goes from 0 to 1 over y, and these are going to be the y values going from 1/2 to 2, and we're integrating the function x plus y. And then we're going to have another integral for the y values going from 0 to 1/2. And for those values, x is going to go from 0 to 2. Now for this integral, this is the integral y equals 1/2 to 2. This, the antiderivative of x plus y, is x squared over 2 plus xy, and we're going from 0 to 1 over y, plus the integral from y equals 0 to 1/2. And now, again, the antiderivative is x squared over 2 plus xy, and over here we're going from 0 to 2. And this is the integral y equals 1/2 to 2. Y is going from, if you look in the brackets here, x is going from 0 to 1 over y. So this is going to be 1 over 2y squared plus 1 dy. Then this is going to be the integral from y equals 0 to 1/2. X is going in the brackets. X goes from 0 to 2. Let me make that look more like a 2. Okay, and when x is equal to 2, this is 4 over 2, which is 2 plus 2y. And now this is a Calc 1 integral, and its value is equal to 3.5. Let me discuss another way to answer this same question. Of course, one way would be to change the order of integration. You'll have a similar problem where you have to split up the integral. But let's look at kind of a different way from those two. So let's first compute the integral over this whole square. So this is going to be the integral from x equals 0 to 2, y equals 0 to 2, x plus y, dx, dy, and then we're going to subtract the integral over this region here that's above the curve, y is equal to 1 over x. Okay, let's do the y integral on the inside. So if you look at vertical line segments like this, for every fixed value of x, y is going to go from 1 over x to 2, and then x is going to go from that point to that point, So x will go from 1/2 to 2 x plus y dy dx. And if you do this, you'll also get the answer 3.5. Now, I don't know which one of those you would rather do. In either case, you have to do two integrals. So you can't really get around that in this problem. I just wanted to illustrate that based on what integrals mean, this is another way to solve the problem.